This video is going to look at some applications dealing with our vectors. And the first one we have here is looking at a gun with a muzzle velocity of 1200 feet per second is fired at an angle of 6 degrees above the horizontal. And we want to find the vertical and horizontal components of the velocity. So here we want to look at a picture of what we're talking about. We have a gun that is fired, and it's fired at an angle of 6 degrees above the horizontal. So that means we have this angle here of 6 degrees. And we could think of this as our vector, and it says it's 1200 feet per second. So here we have 1200. And when it says we want to look at the vertical and horizontal components, that means here we want to look at the vertical part of this and also the horizontal component. So of this 1200 feet per second, how much of this is the bullet traveling in the horizontal direction and how much of that is going in the vertical direction? And because this is such a small angle, it's pretty obvious that most of this is going to be in the horizontal, and there's going to be a little bit in the vertical where with this 6 degrees of elevation. So how can we find that? Well, if we're going to look for the horizontal part, we could really just think of this using our trig functions and a right triangle, because over here we have a right triangle. And the horizontal here, the x, if we're looking for this x part, then we can think of this as our cosine function, because we know that the cosine of our angle is equal to x over r. And if we want to solve for x, then we can multiply by r, so therefore we would end up with x is equal to r cosine theta by multiplying both sides by r. So that's the formula we're going to use if we want to find this horizontal component, is r times the cosine of theta. So if we look at this, then we would have x equals the r value, which is the 1200, multiplied by the cosine of our angle, which is 6 degrees. So if we go to the calculator, we could type in 1200, and that's multiplied by the cosine of 6 degrees. And once again, make sure if you go to your mode that you're still in degree mode. So 1200 cosine of 6, we end up with 1,193, and I'm just going to round that to a whole number here, so 1,193. And that's 1,193, and our units here would be feet per second. So that tells us that for every second, this bullet is going to travel 1,193 feet. So then if we look for the vertical or the y component, then we know that we can use y is equal to, instead of r cosine theta, it's going to be r sine of theta. And that's again because we know that the sine of theta is equal to y over r. So if we solve this for y, we're going to simply get r sine of theta. So if we use y equals r sine of theta, we're going to have 1200 sine of our 6 degree angle. And here we're going to end up with, going to the calculator, 1200. And this time we'll use the sine function. And obviously this is going to be smaller. We get 125. So we would have 125 feet per second. And we can tell, like we said before, this is a small angle. So most of this velocity of the 1200, most of that's going in the x direction, and then a small amount is going in the vertical direction. Okay, we have one more application problem here, and this one is dealing with a ramp, and it says that we have a force of F pounds is required to pull an object weighing W pounds up a ramp inclined at theta degrees from the horizontal. And it says we want to find the force F when W is equal to 100 pounds and theta is 12 degrees. All right, now before we actually start into this problem, let's kind of get a general idea of what we're talking about. We have a ramp, and so therefore we're going to have a right angle, and we have an angle theta. You know, what is the elevation here? What's the incline of this particular ramp? And we have some object here on the ramp. Now, there's three forces that I want to talk about. We have a force F, which is, I'm going to call this F, which is going to be parallel. And that is kind of the force here. We can think of it as the force that's pulling down on this object. Okay. And then we have gravity. And essentially that is how we would calculate what's the weight of the object. And that's the force that is pulling here straight down. And then we have a force that is going to be perpendicular. And when I say perpendicular, that means it's going to be perpendicular to the ramp. So it's going to come down this direction, and that's going to make a right angle here. So this is the force that's going to be perpendicular. So that's kind of the three forces that we're going to focus on. Now for this problem, we're actually looking for the force that's required to pull an object up the ramp. So here, that's going to be this force here that's parallel. So we want to know what force is required. We know that there's some amount of force pulling down this object, and what we want to find is the force that we need to pull in this direction in order to pull this object up the ramp. So let me move this over and let's look at what we have. So here's our ramp. We have our angle theta, which is 12 degrees. Okay, here's the object, and now we know there's a force here pulling down, and for our question is we're looking at a force that's going to be pulling up, so I want to look at this force that we need here. So this is force F that we're looking for. And then of course we have the weight, which is 100 pounds. That's the force, the gravity that's pulling straight down here. So there's 100. Okay, so that side's 100. And then the perpendicular force that's here. Now, what I'm going to do is we have this force F is what we're looking for. We can actually move that force down here. Remember we talked about moving vectors before, so all we're going to do is move this vector. Notice it has the same magnitude and it has the same direction. It's just I'm moving it down here so that we now have our triangle. And because this force here is perpendicular, we know that we're going to end up with this as our right triangle here, or this is going to be the right angle. So what we're looking for is this force here, F, the blue, is how much we need in order to pull this object up this ramp. Now, let me redraw this over here a little bit bigger so we can work with it. We have, this is our 100, this is the gravity pulling down, and then we have this perpendicular force, and then the force that's required to pull this thing up the ramp is here. So this is the force we're looking for. And we notice we have this angle of the ramp is 12 degrees. And based on similar triangles, this angle up here is also going to be 12 degrees because it's going to match up with this angle of the ramp. So notice here we have an angle. We have, this is the right angle here. So we have this angle. We're looking for the opposite side, which is F, and we have the hypotenuse here. So if we're looking for F, we can find that using what trig function? Well, what trig function deals with opposite over adjacent? Well, that would be our sine function. So if we think of our sine function, sine of theta is equal to y over r. So in this case, it would be f over 100. Okay, So let me go ahead and fill this in. I'll just write it. So we have sine of theta is equal to y over r. So for our case then, that means we would have the sine of our angle, which is 12 degrees, is equal to the opposite side, which is the f, and the hypotenuse is 100. So we would end up with 100, the sine of 12 degrees is equal to f. So then if we go to the calculator, we can type this in: 100 sine of 12 degrees, and we end up with 20.79, so we can maybe make that 20.8. So here, this force is equal to 20.8, and that's going to be 20.8 pounds. Okay, because up here we were talking about our weight, we're talking about pounds. So here, the force that's required in order to move this object up is going to be 20.8 pounds. Now, of course, if we were trying to find this other perpendicular force, and maybe I'll call this force, I'll just label this side as X maybe. If we were looking for that, then we would use 100, whoops, not the sine, then we would use 100 cosine of 12 degrees. Okay, so that would find this side because this is the adjacent side. So then if we were looking for that, we would have 100 cosine of 12, which we would get 97.8 pounds of force. So that's how much force is acting here down against the side of the ramp. All right, so what we're looking at here is we're trying to break this into the components to make this up. So here we have the force that's going perpendicular, the force parallel of the weight. So this weight that's being pulled down is broken into the other two forces here. Just like if we go up to the example with the gun, when we fire this gun, part of that is traveling in the horizontal x direction, and part of this velocity is going in the vertical y direction. And that's where we're breaking this down into our components. So any problem here you have something that's dealing with a vector, we can always break it down into its x horizontal and y vertical components.